Okay, hello everybody. My name is Keanu Gomes, and this is the ClimateWins Part 2 presentation. So we'll be going over my proposal strategy for predicting European weather variations using machine learning. And let's get started going over our contents list here. So we have our what is that we just looked at. We'll be going over our objectives next. We'll have our summary for our thought experiments. We will go over the machine learning options and algorithms that I have conducted in the past for this project, as well as the three thought experiments and their methods that ClimateWinds should use when going forward with their project and their objectives. And so we'll have our recommendations after that and just a small outro, quick thank you, questions, and comments. So let's get started. So our project objectives here are to identify weather patterns outside the regional norm in Europe, to determine if unusual weather patterns are increasing, to generate possibilities for future weather conditions over the next 25 to 50 years based on current trends, and finally to determine the safest places for people to live in Europe over the next 25 to 50 years. So basically what we'll be going over is a quick summary of the three thought experiments that I will try to implement implement into a proposal strategy for ClimateWinds in order for them to kind of see where the machine learning models can take them in prediction, to see kind of where theoretically we could push the lines with tech, and mainly we want to answer their objectives. So I've come up with this idea that we have advanced weather detection and location optimization. And so I've come up with three ideas here. One of them is to look into weather pattern detection using generative adversarial networks with audio classification and satellite imagery. I think if we could couple these two together, we could come up with some really cool tech that, if we don't have already, would be pretty cool to check out. Number two, explore the concept of live weather vehicle alerts, data collection and retrieval based on conditions for safe travel. And number three, develop a model to determine optimal locations for new homes, vacation spots based on environmental factors. So basically, the idea behind this is to come up with a method using machine learning algorithms to try to not only answer the objectives for ClimateWinds, but also come up with some cool ideas that maybe can be implemented into the future if they aren't already. And we could touch more on these in a second. So going over the quick machine learning options that we've have for this project and what I've conducted so far. So the random forest algorithm and GANs used with CNNs. CNNs are the convolutional neural networks, produce the highest accuracy and lowest loss predictions. So out of all the machine learning models we've tested and iterated over the last month or last 2 months, we've gone over supervised learning and unsupervised learning models where the decision tree, artificial neural networks, and random forest, we have their scores down there. Out of the supervised learning models, it seems that the random forest performed the best at 88%. Unsupervised learning models that we've gone over k-nearest neighbors, convolutional neural networks as mentioned, and generative adversarial networks. And so you can see the scores below. Generative adversarial networks has proved to be the highest accuracy out of all the models. And so what we want to look at moving forward, going into these thought experiments, is we want to remember that so far we have random forest and generative adversarial networks, as well as CNNs, because we use CNNs in generative adversarial networks. These are our highest scoring models with the lowest loss. So we want to be mindful going into that these are of recommendation. And so the first thought experiment I have is the time capsule model, the climate time capsule, excuse me. So what is it? Imagine creating a virtual time machine that shows us how climate change could alter our world over the next 25 to 50 years. It's like using a complex puzzle solving app that can predict pictures on the puzzle based on pieces from the past and present. So we have a puzzle, we put a little bit together, and then we basically go, okay, well, let's use this computer right here to guess what the rest of the image is based on its current and its past inventory of items we haven't used yet. And so it could predict a climate change model. And so the machine learning role here is that we'll use neural networks, random forest, and gradient boosting machines. Gradient boosting machines would be used in tangent with random forest and decision tree models, while neural networks could be used for CNN and recurrent neural networks, excuse me. And so the data we'll need beyond this, beyond historical weather, is the environmental policy surrounding Europe, socio-economic data, biodiversity records, and we would need a lot of human input too as well. So as we worked with our pleasant data binary outcomes in our last data set, we would also want more human survey in the form of open source. And so other use cases for this climate time capsule could be, obviously future preparedness, disaster planning, safe living, but we could also think about real estate investment, agricultural benefits, and business development. So, commercial, we have a very important business. Let's say we have oil companies, or we would want to locate them in an optimal location where there's, you know, least likely chance that they'll have a disaster, an environmental disaster. Moving on to our thought experiment number 2, the Climate Symphony Orchestra. So what is this? So this is about listening to the Earth's music. I come from a background in music and audio engineering, so I find this typically interesting to me. And so this is about listening to the Earth's music, the sound of rain, wind, and wildlife to understand weather events. So imagine in this experiment, we use audio classification to listen to the Earth. A network of sensors placed around Europe collects audio data, capturing the sounds of the environment. Wind gusts, uh, precipitation, hail, anything that can make a noise in the realm of a storm without human noise interference. This could work out and I think could be used for a great prediction model in the future. However, this could be more resource heavy. Um, it will require a lot more processing, a lot more equipment maintenance. And so, but the machine learning role here is that we'll use audio classification models. We could use CNNs and GANs for image classification as well. And we use those together to create a prediction model and create simulations of these predictions and create other simulations of these predictions that we may have not seen before. And so we test against these variables, and what we would need is beyond the historical weather data set is audio recording, satellite imagery, correlation data between sounds, images, and weather events, and anthropogenic noise data. So this removes human noise. So if we could also implement the anthropogenic noise data system where it could filter out automatically how, let's say an equalization would work when you're engineering vocals or, the bass on that new track. So the Climate Symphony Orchestra is very interesting to me, but I think it would require more resources and it would be more time consuming, more maintenance heavy. And so the final thought experiment I have is called the Safe Haven Map. And so what this one is a map that helps us find the safest places to be during extreme weather events, which are becoming more common due to climate change, as we know. And so it's basically similar to a navigation app that doesn't just give you the fastest route, but also the safest one based on current and predicted conditions. And so we would use machine learning models such as neural networks, k-means clustering, and dimensionality reduction, such as principal component analysis. Because we would have so many variables and we would want so much data, the data would become so complex, the dimensions would become huge, and so we would want to save as many attributes to that data as possible while also reducing the variance. So in other use cases here, we have safe living areas, vacationing, visiting, real estate, investment, and vehicle tech. Um, I think these are all great. Um, Mainly touching on vehicle tech, I think vehicle tech could also be used to gather data and to uh, be used as kind of as a base system or as a net system in order to capture more variance in weather conditions that we may not be getting from satellites. Okay, so moving on here. So what thought experiment has the most potential for answering ClimateWins objectives, right? The most potential is the climate time capsule, because this offers a comprehensive simulation of long-term climate impact, but it also considers the effect, the resources, and the equipment's maintenance behind, let's say, doing the Climate Symphony Orchestra, because we would need to place sensors around, optimal locations around Europe. Beyond that, they would need maintenance. This is cost heavy. This is process heavy. Uh, this is infrastructure heavy. So but yeah, so the time climate capsule. But if those things weren't, so if processing and cost being cost efficient and maintenance wasn't a thing, I'd say all three thought experiments, because all these algorithms can be used together, and so the only thing we would really be thinking about is equipment maintenance and just the ongoing maintenance of these sensors and the data that could be gathered from it. And so that's basically it. How it can be accomplished? Well, we'd use predictive analysis, pattern recognition, data clustering, time series forecasting, and data simulations with generative adversarial networks. And so there's a whole bunch of other models that could do this as well. We have neural profit from this is a Facebook profit model, formerly known as Facebook profit. They have the profit model and the neural profit model. The neural profit is newer and it is slightly better for forecasting complex data. These also handle missing values. um, we could also do the long short-term memory model. All of these models work with time series data. I don't believe decision trees works with time series data, but yeah, these would be the recommendations for ClimateWins. Thank you for your time. This concludes my proposal strategy. And any questions or comments, please email me below. Check out my website, my portfolio, my GitHub scripts, and connect on LinkedIn. Thank you so much.